Hello dear friends, I hope everybody will be fine. Today I will discuss shear force in bending moment and also shear force in bending moment diagram of simply supported beam which the load is acting at a center of the beam. Look at here first, shear force and bending moment bending moment shear force and bending moment. Look at here dear friends, this is a beam which is a have to support simply supported beam. The load is acting at center of this beam W. Total this length is called L. Total is L, but this is also L by 2. This distance, this is also L by 2. This is A in B, which is a half RA in RB. We have this simply supported beam. AB is called a simply supported beam. Total length is L, in which the load is acting from center point or midspan from A to C. This is a C. A to C is called L by 2. This distance. In C to B, this is also L by 2, because the load is acting in this center point, which the length is divided by 2. Now we will find shear force in bending moment. Shear force in bending moment. First of all, we should know all summation of vertical force is 0. All summation of horizontal force is also is equal to 0. Summation of Fy is equal to 0. Summation of Fx is equal to 0. Fy is nothing but that is a vertical force, and Fx is equal to that is a horizontal force, but there is no exist horizontal force, only vertical forces exist. We will calculate now. Look at here dear friends. First of all, we should find the reaction RA in RB. RA in RB we should find. After that we can find easily shear force in bending moment. Look at here, RB is acting upward. Force is positive, downward force is negative. That is same convention of shear force. RB into L. Why L? Because this is total entire span is L minus W, which is W is acting at a center of this beam. W into L by 2. W into L by 2 is equal to 0, because all summation of vertical forces is equal to 0. Now we should find RB. RB into L is equal to, we should convert to or transfer at left side W L by 2. This L will be cancelled to this L. What? W R B is equal to W by 2. W by 2. This is a RB. Now we will find what? We will find RA. RA is equal to, we should remember this formula, total load minus RB. This formula we should remember we can find easily ra value. Look at here, dear friends. ra is equal to total load. What is total load? Total load is a w minus rb value is how much? W by 2. We should find here 2 into 2w minus w is equal to w by 2. This is a ra, sorry for that. Ra is equal to w by 2. Dear friends, please remember, if we have simply supported beam but load is acting at a center point, in that case ra is also equal to rb. Ra is equal to rb. Please remember this point. We find the reaction force. We find the reaction. Now we will find what? We will find shear force in bending moment. Here, look at here, dear friends. Shear force. Now calculation of shear force. Calculation of shear force. We should find now shear force calculation. Here, this is upward force. This one. This if we find the shear force, we should take this right side or left side. We should take anyone as a sign convention. As a sign convention, negative or positive, but we should take this one negative. We should keep it negative. rb, there will be rb is equal to how much? Rb is equal to w by 2, and also ra is equal to how much? Same, ra is also w by 2. W by 2. Ra in rb is also w by 2. Now we will find, look at here, there is no exist, only rb is there, but shear force at a point of b point, shear force is equal to sf mean shear force. In b point, shear force is equal to w by 2, but negative. We should, before I discuss, we should keep it negative. Between b and c there is no load. Shear force is only minus w by 2. Now we will find the left position. We will find the shear force at right side at a. SF means shear force. Look at here. SF at a point A is equal to SF at a point A is equal to what? This is also acting. We should keep it positive. And clockwise force we should keep it positive, but anti-clockwise force we should keep it negative. R w by 2, that is a shear force at a point. We should find the shear force at a c. SF at a c point. We should find the shear force at point of c. Look at, dear friends, we have from b we will calculate from b minus w by 2, and also we have, there is a positive w by 2a at a point of a. This will be cancel. This minus w by 2 will cancel. This is equal to 0. is equal to 0. That's why at a point of SF, at a point of C is equal to 0. Dear friends, please remember, when the load is acting at the exact point, there will be the shear force will be 0, but there will be moment will be maximum. Please remember this point. When the shear force is 0, in that point the bending moment will be maximum. When the bending moment is 0, in that point shear force will be maximum. Look at here, dear friends. Now we calculate SF at B is equal to W by 2 minus W by 2 first, and second point SF at A is equal to positive W by 2, and third SF at C is equal to 0. C is equal to 0. We should find now calculation of bending moment. Calculation of bending moment. We find the reaction first. First we find reaction, and second we find what shear force. Now we will find in third bending moment. In third we should find bending moment. Calculation of bending moment. Calculation of bending moment. Now look at here, dear friends. Please remember this point. At support the bending moment will be 0 at A in B, and at A in B. But why? Because there is no force exists. The definition of bending moment, force into distance, is called bending moment. That's why it will be 0. In the support, the shear force, the bending moment will be 0. Please remember this point. Please remember, bending moment at B is equal to 0. First point. Second point. This is the first. Second point. Bending moment at a point of A. At a point of A is equal to also 0, because this is a supporter. That's why the bending moment is 0, but shear force is in that point maximum. Now we will find bending moment at a point of C. In third point, bending moment at a point of C is maximum. Bending moment at a C. Look at here. Now we will calculate the bending moment at a point C. R B into this distance. Look at, dear friends, RB into L by 2, because moment we will find the right side, RB into this distance B to C, because when we find right side or left side, that will be equal. The bending moment should be equal. Right side and left side should be equal. RB into L by 2. RB into L by 2. L by 2. What is RB? We should substitute the value of RB. RB is equal to W by 2. RB, look at here. RB is equal to W by 2. We should substitute W by 2 into L by 2 is equal to WL by 4. WL by 4. This is the moment at a point of C. That is right side we find. We should find left RA into L. RA into L by 2. RA we will substitute also W by 2 into L by 2. That is equal to WL by 4. Both is equal to. Bending moment at that point is same. Both is same. Now we will draw the shear force in bending moment diagram. There, look at here, dear friends. We will draw here the moment. This is the simply supported beam. Look at here. This will be simply supported A, B, but the load is acting in this center point W. This is C. This point is C. Total is L, but there is L by 2. This is also L by 2. L by 2. Look at here, dear friends. I will extend this line. This is this one. Now this point and this point we'll keep it. At a point of A, the shear force is how much? Shear force is W by 2 positive. At a point of P, the shear force is W by 2 but negative. In between A and C there is no load, because there is no load at a straight point. We should keep it. And also we should keep it here. Shear force between B and C there is no load. Straight line we should keep it. There will be 0. It will become down. This is the shear force diagram. This is a positive. This one. This is a negative. This diagram is called shear force diagram. Look at, dear friends. This diagram is called shear force diagram. This diagram will be shear force diagram. This lane is called base lane. This lane is called base lane. This lane is called base lane. Now we will find the bending moment. This line we will extend. We will extend here. Look at, dear friends, here. A, B, B, A. Okay. Before I show to you, I find the shear force at A is 0, B is also 0, but only C point. There will be C point. There will be C point. It is a maximum. Shear force will be maximum. Shear force will be maximum. Please remember, if the shear force diagram is straight, bending moment is inclined. Please remember, dear friends, if the shear force diagram is inclined, the bending moment diagram should be parabolic. This point is equal to WL by 4. From WL by 4, this is a positive, we will this one. Look at, dear friends, this is a positive bending moment diagram. This is a I will show you clearly, dear friends. This is the shear force bending moment in also shear force diagram. This one, this is the bending moment diagram. Bending moment diagram. This is bending moment diagram. This is a shear force diagram. Shear force diagram. This is bending moment diagram. Dear friends, this is a short video. Please subscribe to my channel for more update videos. In next video I will discuss a example of this simply supported beam. Please subscribe to my channel. Don't forget like and share with your friends. Goodbye, dear friends.